Jessie drew the following triangle. She labeled the first side as 9 and the second side as 10. At that point, her sister walked in the room and asked her if the triangle was a right triangle. Jessie said yes, and she drew this box in the corner. If this is a right triangle, do you know how to figure out the length of side C? To figure out the length of side C, we are going to need to use a formula called the Pythagorean theorem. The Pythagorean theorem states that for any right triangle, a squared plus b squared will be equal to c squared, where a and b are the two shorter sides of the triangle and c represents the hypotenuse. Now let's look at Jessie's triangle once again. Jessie's triangle has this side being 9 and this side being 10 and c being missing. So we can substitute 9 in for a and have 9 squared plus b squared, which is 10 squared, and all that's equal to c squared. 9 squared is 81 plus 10 squared, which is 100, is equal to c squared. 81 plus 100 is 181, is equal to c squared. Now because we want the length of c, we can take the square root of both sides. This cancels, gets c alone, and the square root of 181 is 13.45. Now, we figured out the length of c. Can you use the converse of the Pythagorean theorem to make sure your work is accurate? Here's how we do that. First, take the Pythagorean theorem again. A squared plus b squared equals c squared, and let's substitute all of the known values in for a, b, and c. We would have 9 squared plus 10 squared is equal to 13.45 squared. 9 squared is 81 plus 10 squared, which is 100, is equal to 13.45 squared, which is 180.9. We can round 180.9 up to 181. Now we do want to change the c equals 13.45 to c is approximately 13.45. We use approximately because it's an approximate value, because if you look back here, we rounded 180.9 to 181. So it's not exact, but it is definitely close. Using the Pythagorean theorem, the converse of the Pythagorean theorem, and right triangles, we can find missing sides.